we are here at Aristotle University of Thessaloniki. I have a pleasure to be with Professor Nektarios Tavernarakis. He presented a very interesting paper on aging, in human aging. That's why we thought an interview with him would be perfect for our goals. Professor, please tell us something about your research and how it helps human life.
So in our laboratory we are investigating aging, as you said. Aging is a universal phenomenon. It concerns everybody, every one of us. It's still a mystery in a large extent, so we don't really understand most of the mechanisms that regulate aging. So that's why we are investigating aging using various model systems or organisms. And what we've identified is molecular mechanisms that contribute to aging, and how we can intervene, how we can regulate these mechanisms to influence aging and age-related pathologies. This research has the potential to lead to interventions that will enhance the quality of life during old age, but also battle diseases that are associated with aging, because this is one of the biggest questions of current aging research. Not just or simply how to extend lifespan in humans, but how to make old age free of disease and pathology.
So to improve the quality of life, because you can have a long life, but the quality goes down.
Exactly.
So this will help in this direction.
Yes.
Yeah, and then what is related to this is that sustainability. Sometimes there are various theories that our population in the world is really much more than we can handle. And your research will increase a little bit the lifespan, how we can really tackle this issue. Your personal opinion.
It's a difficult question. It's not something easy. I think it will require a lot of additional research. I think though there has been a lot of progress in understanding the basic molecular mechanisms of aging. This is a prerequisite before we can intervene, before we can actually develop therapeutic interventions. We need to first understand, so we don't do more damage when we intervene. We need to really be able to predict the outcome of any intervention. That's why we need to fully understand the process of aging.
At what stage is the research?
Well, at this point, we are doing experiments, as I said, in model organisms. We have plans to move to clinical trials at some point, once we feel that we've covered the ground required to do that, which is to first assess the efficacy of compounds that influence the aging process in model organisms, and then also assess the safety of these compounds when applied to humans.
And the second question is, what attracted you to be a scientist? From the childhood, did you really have a goal to be a scientist, or you were attracted more in other fields of knowledge?
Well, I was curious from the very beginning. I wanted to understand how things work, not just living things, but things in general. I wanted to understand how nature works, and to that end I was reading a lot. I was also very close to an environment that fostered knowledge and education. My parents were actually eager for me to study and go to university and follow a research path.
In science?
In science, yes.
Not in philosophy, not
in science.
In sociology, not specifically science. So it has been your dream from the beginning?
Yes, I wanted to be a scientist. I wanted to be a researcher. As I said, I had a lot of curiosity about how the world works, how nature works. So I had the motivation to follow a research path, and eventually I wanted to have my own lab where I could do my own experiments and design my own research.
And if you go back to your childhood, would you have chosen the same profession?
Yes, absolutely. I would have chosen the same path.
Tell us something about your hobbies. So you are a scientist from the childhood, the dream of being a scientist, and you are now a scientist fulfilling your dreams. What about your hobbies? Related to science or outside science?
Well, some of my hobbies are related to science. I'm a licensed radio amateur, which requires a lot of physics and mathematics. So I try to keep up to date and read a lot. I'm also trying to follow other fields of science. Besides biology, I'm also very interested in physics, chemistry, and mathematics, as well as computer science, because all these disciplines are becoming important increasingly in biology. So if we want to really address important questions, biological questions about life, about the mechanisms of aging, we need other disciplines. So nowadays we cannot do without physics, computer science, or mathematics. They have become an indispensable part of what is biology, and that's why I'm also interested in learning about different disciplines, not just what I've studied through the years in university and what my career path, my research subject has been, but other disciplines as well.
But still we are in the science level. What about outside science?
I like reading a lot of literature, so this is something that I enjoy very much. I also enjoy nature. I'm an outgoing person. I would
Do you
like
swim? You're Greek. Do you swim?
Of course I swim.
How frequently?
Well, almost year round. Here in Crete, my native island, you can swim throughout the year, so it's really easy for us to go for a swim even during winter. It's still doable.
Exercise?
Walking a lot, hiking, these are things that you can do. There are some really nice, beautiful hiking trails on Crete, but also Greece offers a lot of opportunities for outgoing sports.
And how much time it takes? Do you feel swimming or walking, do you feel this takes time from scientific research? It's a good thing or bad thing in terms of the time that they take from your scientific research?
Well, research science is a full-time job. It's something that you do even when you go to sleep, literally. You think about questions, you want to understand, you think towards a problem, towards a question that you had in the lab, some results that you obtained. You always think, so it occupies almost the entire time.
Do you think about science even when you swim?
Well, even then. But I try to find time for extracurricular activities, and of course my hobbies, as I said.
So how human are the scientists? So you are dedicating almost 100% to science. So being a human being is something else. It's a good thing to dedicate 100% to science all the time, or a little bit rather.
No, science is absolutely human endeavor. So it's done by science, it's by people, and it carries all the characteristics of a human endeavor. So scientists are people like everybody else, and I think that what is characteristic is dedication. Most of the times, what you see in scientists is motivation and dedication to what they do. So they are fully committed to understanding, solving a problem. I think that's what makes a successful scientist. Other than that, I think, as in any other human endeavor, you need to try, you need to persevere. If you fail, you need to stand up and continue. It takes a lot of courage. Sometimes things don't go well. Actually, most of the times, things might not go as planned. So you need to be able to persist and move on despite failure, despite any setbacks.
And sometimes family man and our children? Do they complain that dad is not staying too much with us because he's dealing all the time 100% with science?
I think family and science are not incompatible. I have a family, I have two lovely daughters, and I really enjoy being with my family, with my children, and I want to spend time with them. And if you organize your time, I think you can make it. It's not incompatible.
Okay. Thank you very much. I really appreciate it.
Me too. Thank you very much.
Thank you.